My dear students, all of you know that this is my last lecture on electrochemistry, and electrochemistry is actually in the syllabus of MT, and all of you know that we are going to appear in MT very soon, and maximum of you already have got the MT routine, and we'll take your MT in the online. So let's come to the point. My dear students, now we'll study fuel cell. What is actually fuel cell? The cell in which chemical energy converts into electrical energy is called fuel cell. Now, actually, you have to know what is the source of chemical energy. The reaction between fuel and oxidant, chemical energy is produced, which is deposited in the reaction system. Then this chemical energy converts into electrical energy. Now, what will be the standard definition of actually fuel cell? The cell in which chemical energy converts to electrical energy through a chemical reaction of fuel and oxygen or another oxidant is called fuel cell. And hydrogen fuel cell is an example of fuel cell. In this fuel cell, hydrogen gas is used as fuel, and there are three major parts in the hydrogen fuel cell. One is anode, second is cathode, and third is electrolytic substance. Porous graphite with nickel layer is made anode. Porous graphite layer, porous means so many holes like net, is actually porous graphite, and porous graphite with nickel and nickel oxide layer is made cathode. The warm aqueous solution of potassium hydroxide is taken as electrolytic substance. Under high pressure, hydrogen gas is passed through the anode, through the porous anode. Then hydrogen gas reacts with the hydroxide of potassium hydroxide. My dear students, in the aqueous solution, potassium hydroxide ionizes to produce potassium ion and hydroxide ion. This hydroxide ion reacts with the supplied hydrogen gas and release electrons to produce water. Then I have to balance the anode reaction. To make it balance, I have to put here 4, and there are 8 hydrogen atoms at the right side. That's why I should give here 4 hydrogen atom, and 2 into 2 4, total 4 plus 4 8 hydrogen atoms at the left side of the anode reaction. And hydroxide ion contains one negative charge. That's why one hydroxide ion releases one electron. That's why 4 hydroxide ions release 4 electrons. And come to the cathode. In the cathode, atmospheric oxygen is passed through the porous cathode as oxidant. The supplied oxygen reacts with the water of aqueous solution and accepts electron, which is released in the anode to produce 4 hydroxide ions. Here actually I also balanced the reaction for hydroxide ions, so there are 4 hydrogen atoms, and at the left side 2 into 2 4 hydrogen atoms, and at the right side 4 oxygen atoms, at the left side 2 oxygen atom plus 2 oxygen atom equals to 4 oxygen atoms at the left side. My dear students, it is stated that at the anode 4 hydroxide ions are given. That's why at the cathode 4 hydroxide ions are produced here, which will be crossed out during the addition of both of the anode and cathode reactions. Then after addition, 2 molecules of hydrogen plus 1 molecule of oxygen and 4 hydroxide ions and 4 hydroxide ions are crossed out with one another, and electrons are crossed out also. And at the left side there are 2 molecules of water, and the right side there are 4 molecules of water. So after subtraction of water molecules from right to left, the remaining water molecules are 2 molecules. So the resulting reaction is 2 mole of water plus 1 mole oxygen. As a resulting reaction, 2 molecule of hydrogen plus 1 molecule of oxygen, and the react together to produce 2 molecules of water. That's due to the flow of electrons from anode to cathode, the electricity is produced, and it is stated that at the anode nickel and at the cathode nickel and nickel oxides are used here as catalyst, and they accelerate the rate of reaction. They accelerate the rate of cell reaction, and also they accelerate the rate of anode half reaction and cathode half reaction. That's all about the hydrogen fuel cell. My dear students, now we will study storage battery or secondary cell. Storage battery is actually in our car or IPS in our household purpose. The used batteries are actually storage battery. Those batteries can be charged, and during the using it is discharged. So what will be the definition of storage or secondary cell? The cell in which electrical energy is converted into chemical energy by passing electricity from external source and is stored in the cell. Then this chemical energy may again be transformed into electrical energy, is called secondary or storage cell. Actually, if you want to memorize it shortly, the cell which is charging and discharging both can be occur simultaneously, both a process can be occur simultaneously, is actually secondary cell or storage cell. Now we'll discuss a secondary storage cell, lead storage battery. Lead storage battery is used in the car, and in the lead storage battery, lead strip, there are 3 parts in the lead storage battery: anode, cathode and electrolytic substance. Lead strip is used as anode, and lead strip with lead oxide layer is used as cathode, and sulfuric acid with 1.15 relative importance is used as electrolytic substance. 1.15 relative importance. Lead of anode releases 2 electrons to form Pb2+. And my dear students, in the aqueous solution, sulfuric acid ionizes to produce 2H plus ion and sulfate ion, SO4 2 minus ion. This lead Pb2 plus ion combines with sulfate ion of sulfuric acid to produce solid lead sulfate. This reaction occurs in the anode. So in the anode reaction, I can write lead plus sulfuric acid equals to lead sulfate, and from sulfuric acid 2 hydrogen ions are produced and 2 electrons are released by lead. I mean Pb minus 2 electrons, but I have written 2 electrons at the right side. That's why it is plus 2 electrons. Again, come to the cathode reaction. In the cathode reaction, you know that lead oxide layer is used as layer on the surface of lead strip, and in the lead oxide actually lead exits as 4 plus ion, Pb 4 plus ion, and this 4 plus ion, Pb 4 plus ion of lead oxide accepts 2 electrons which are released in the anode to form Pb2 plus ion. This Pb2 plus ion again combines with the sulfate of sulfuric acid to produce lead sulfate. Now the reactions of the cathode, if I can write here, lead oxide plus sulfuric acid plus those 2 hydrogen H plus ions and those 2 electrons released from the anode are accepted in the cathode to produce lead sulfate and water. Actually there are 2 H plus ions and 2 hydrogen atoms in the sulfuric acid. 2 H plus and those 2 hydrogen atoms combines with 2 oxygen atoms to form 2 molecules of water. Then I have added both of the anode and cathode reactions. Lead plus lead oxide plus 1 sulfuric acid and 1 sulfuric acid, 2 molecules of sulfuric acid, and these 2H plus ions are crossed out with the 2H plus ion of right side of anode reaction. Then those 2 electrons are also crossed out, and at the right side lead sulfate and lead sulfate, there are 2 times of lead sulfate. That's why I have written here 2 PbSO4 and plus 2 water molecules. That's all about the reactions during the discharging process. But after lead sulfate, when the solid lead sulfate will be deposited on the surface of both anode and cathode, the reaction will be stopped. In that case, we have to understand that the charge is actually finished. In that case, we have to charge again the battery, and during the charging those anode reactions and cathode reactions will change. In that case, the cathode reaction will occur in the anode and the product will be reactant and the reactants will be product. And again the reaction of anode will go cathode reaction and the product will be reactant and the reactant will be product. And in the cell reaction, the product will be reactant and the reactants will be product. That's all about the lead storage battery. Due to the releasing and accepting electrons, the electricity is produced in the lead storage battery. Actually, during the discharging,
the chemical energy converts into electrical energy, and during the charging the electrical energy from external source converts into the chemical energy, and this chemical energy is deposited in the lead storage battery. That's all about the storage battery, and this is very important, my dear students. My dear students, here I have used 1.15 relative importance of sulfuric acid as electrolytic substance. You have to understand that 1.15 relative importance of sulfuric acid means the density of sulfuric acid, the ratio of density of sulfuric acid, and the density of water at 4 degrees centigrade temperature is called relative importance. So the density of sulfuric acid divided by the density of same volume of water at 4 degrees centigrade temperature is actually 1.15. Now after occurring the reaction, the used water, a small amount of used water is removed from the storage battery due to the vaporization. That's why during the charging we have to add water in the lead storage battery for decreasing the density of sulfuric acid. Due to the removing water, the density or concentration of sulfuric acid is increased. That's why to make it dilute or to make it to convert it to the previous concentration, a small amount of water has to be added in the lead storage battery during the charging. My dear students, now we will study lithium ion battery. You know that lithium ion battery is a rechargeable battery. As it is a rechargeable battery, it is a secondary cell or a storage battery also. And I am showing you two different figures. One is for discharging and another is for charging. All of you know that in the mobile set or laptop we are using lithium ion battery. When we are using battery, that time discharging, charging is used, charge is used, and after finishing the charge we again plug the battery in the external electrical source. That time charging is occur. However, in the lithium ion battery there are three prime parts. One is anode, second is cathode, and third is electrolytic substance. Anode. Graphite is saturated by lithium used as anode, and lithium compound like lithium cobalt oxide or lithium iron phosphate is used as cathode. My dear students, I have written here graphite is saturated by lithium. Actually here lithium is not bonded with graphite carbon, it is just given as a layer. Lithium graphite is coated by lithium. This is one kind of coating, I think. Electrolytic substance, lithium salt dissolved in organic solvent is used as electrolyte. Organic solvent means it may be ethyl alcohol or any other liquid alcohol or carbon tetrachloride. Those type of solvents are actually organic solvent. And lithium salt, suppose lithium hexafluorophosphate, this is a lithium salt which is used in the lithium ion battery as electrolytic substance. In the anode, lithium saturated graphite, lithium saturated graphite releases an mole of electrons to form an mole of lithium 3 plus ion, and graphite is separated here. And in the cathode reaction, lithium cobalt oxide accepts the electrons released in the anode to produce lithium cobalt oxide. Here actually the produced n mole of lithium ion and n mole of electrons are accepted by lithium cobalt oxide to produce lithium cobalt oxide. Here actually n equals to mole number of lithium atom, but the mole number is less than 1. After accepting n mole of lithium ion, it converts into LiCoO2 as a product. Due to the releasing and accepting electrons, a flow of electricity is produced. That's why we can get electricity or current from the lithium ion battery. And again, during the charging, I have shown you discharging reactions, but during the charging, the reaction of cathode will be at the anode and the product will be as reactant. The product lithium cobalt oxide will be reactant at the anode, and the reactants lithium 1 minus n CoO2 plus n mole of lithium ion plus n mole of electrons, those reactants will be the product at the anode. And again, the reaction in the anode will be cathode. The products will be reactant and the reactant will be product during the charging. Actually, during the charging, cobalt 3 plus ion is oxidized and releases electron to form cobalt 4 plus ion, and during the discharging, cobalt 4 plus ion accepts electron to form cobalt 3 plus ion. Cobalt 3 plus ion is oxidized during the charging. Cobalt 3 plus ion releases electrons to form cobalt 4 plus ion during the charging. This is the actually charging part, and oxidation reaction occur in the anode. Actually, I mentioned here cobalt of lithium cobalt oxide. Here the oxidation or the charge number of cobalt in lithium cobalt oxide is actually plus 3. I have calculated the charge number or oxidation number of cobalt in lithium cobalt oxide. I have shown you. And in the product, lithium 1 minus n cobalt oxide. Here actually lithium 1 minus n cobalt oxide molecule, lithium is not bonded with actually cobalt oxide. Lithium is given as a layer of cobalt oxide, or lithium is actually used as coating. Cobalt oxide is coated by lithium. That's why the oxidation number of or charge of lithium will not be calculated here. So let the oxidation number of cobalt is X and oxygen is minus 2. So the oxidation number of or charge number of cobalt is plus 4 in this compound. So I can say during the charging process, cobalt 3 plus converts into cobalt 4 plus cobalt 3 plus converts into cobalt 4 plus through releasing an electron. Again, cobalt 4 plus is reduced during the discharging. So during the discharging, this is a reduction reaction. Of course, during the discharging, the reaction occurs in the cathode as it is a reduction reaction. So Li1 minus N cobalt oxide, in this case already I have shown you the oxidation number of cobalt is plus 4, already I have shown you, and lithium cobalt oxide, this is 3 plus. That's why the charge number of cobalt 4 plus converts into cobalt 3 plus through accepting an electron. Actually, due to the releasing and accepting electron, electricity is produced. That's all about the lithium ion battery.